Hello friends, we have learned many theorems related to circles in this chapter. So let's start this video by revising all those theorems. The first theorem was equal chords subtend equal angles at the center of the circle. That is, in this circle with the center O, if AB and CD are chords of equal length, then the angle AOB is equal to the angle COD. The second theorem was a perpendicular from the center of the circle onto a chord bisects the chord. That is, in this circle, if AB is the chord and OC is the perpendicular to the chord, then the length of AC will be equal to the length of CB since OC bisects the chord AB. The third theorem was one and only one circle can be drawn through three non-collinear points. That is, if there are 3 points which do not lie on a straight line, then we can draw only one unique circle passing through all the 3 of them. The fourth theorem was based on the concept of a distance between a point and a line. That is, in a circle, if there are 2 chords which are at an equal distance from the center of the circle, then those 2 chords are of equal length. That is, in this circle, if the chords AB and CD are at an equal distance from the center of the circle, then the length of the chord AB will be equal to the length of the chord CD. Then we learnt about the angle subtended by the arc. That is, the angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at the circumference of the circle. That is, in this circle, if the angle ABC is 60 degrees, then the angle AOC is 120 degrees. Now let's make an important observation from this theorem. Now here is a circle with center O and AB is the diameter of the circle. Now tell me, what will be the angle ADB? If you observe carefully, AB is a straight line and the angle AOB is the angle subtended by the arc ACB at the center of the circle. Now since AB is a straight line, the angle AOB will be equal to 180 degrees. Now we know that the angle subtended by the arc at the center of the circle is twice the angle subtended by the arc at the circumference of the circle. So therefore the angle ADB will be half the angle AOB. So we can conclude that the angle ADB is equal to 90 degrees. So from this we can conclude that the angle subtended by the semicircular arc on the other semicircle is 90 degrees, or the angle subtended by the diameter of the circle on the circumference of the circle is also 90 degrees. The next theorem was related to the angles in the same segment. That is, angles subtended by a chord or an arc in the same segment are equal. That is, in this circle, if the angle ACB is equal to 40 degrees, then the angle ADB will also be equal to 40 degrees since they are the angles in the same segment. Now, this theorem will lead to an intuitive question, which is regarding the angles in the different segments. Is there a relation between them? Let's try to figure it out. Now, here is a circle with the center O and AB is a coordinate. The angle ACB is the angle in the major segment and the angle ADB is the angle in the minor segment. Now let's try to figure out a relation between these 2 angles. First, let's assume the angle ACB to be x degrees. Now we have to find the angle ADB in terms of x. If we join OA and OB, we get the angle AOB. And we know that the angle AOB will be 2x degrees, since it is the angle subtended by the chord at the center of the circle, and we know that it will be twice the angle subtended at the circumference of the circle. Now the reflex angle AOB will be 360 minus 2x degrees. And we know that this angle will be twice the angle ADB, which implies that the angle ADB will be half the angle AOB, which is the reflex angle. So therefore the angle ADB will be half of 360 minus 2x, which is nothing but 180 minus x. So therefore the angle ADB is 180 minus x degrees. So the angle ACB is x degrees and the angle ADB is 180 minus x degrees. Now if we add both of them, we get the sum of these two angles equal to 180 degrees. Therefore, we can conclude that the sum of the two angles subtended by the chord in two different segments is equal to 180 degrees. Finally, the last theorem was, in a cyclic quadrilateral, the sum of opposite angles is equal to 180 degrees. That is, if there is a quadrilateral such that through all of its vertices a circle can be drawn, then in that quadrilateral the sum of the opposite angles will be equal to 180 degrees. So these are all the theorems that we studied in this chapter. Now let's do some problems related to these theorems. So here is our first problem. In this problem we have been given two angles and we have to find the angle BDC. As soon as we look at the figure, we can clearly see that the angles BAC and BDC are the angles in the same segment. And we know that the angles in the same segment are equal. So the angle BAC is equal to the angle BDC. Now if you observe carefully, in the triangle ABC, we know both the angles ACB and ABC. So we can find the angle BAC from this information using the angle sum property. So therefore the angle BAC will be equal to 180 minus 69 minus 31, which is nothing but 80 degrees. So the angle BAC is 80 degrees. Now we also know that the angle BAC is equal to the angle BDC, since they are the angles in the same segment. Therefore the angle BDC will also be equal to 80 degrees. That's it. We have successfully completed this problem. Now let's move on to the next question. So here is the second question. Pause your screen and read the question carefully and try to attempt it. First, let's draw the diagram so that we can solve it easily. So it is given that ABCD is a cyclic quadrilateral. So first, let's draw a quadrilateral ABCD. Since it is cyclic, we can draw a circle passing through all of its vertices. So here is the cyclic quadrilateral ABCD. Now it has been mentioned that the diagonals meet at the point O. So the diagonals are AC and BD, and the intersection point of those two diagonals is the point O. Now don't consider the point O to be the center of the circle, because it is not mentioned in the question. Until and unless it is mentioned in the problem that O is the center of the circle, then only we have to assume it. Otherwise we shouldn't. So keep this point in mind, because you are prone to do these sort of mistakes. So the point O is the only point of intersection of the two diagonals in this quadrilateral. Some angles are given as well. That is, the angle DBC is 70 degrees and the angle BAC is 30 degrees. Now let's start solving this. It is given that the angle BAC is 30 degrees. Now what will be the angle BDC? The angle BDC will also be equal to 30 degrees since the angles BAC and BDC are the angles in the same segment, and we know that the angles in the same segment are equal. Using the same logic, the angle DAC will be equal to the angle DBC since they are the angles in the same segment. So the angle DAC is equal to 70 degrees. Now that we have the angles BAC and DAC, we can find one angle of this quadrilateral, that is the angle BAD. The angle BAD is the sum of the angles BAC and DAC, which is nothing but 30 degrees plus 70 degrees, and therefore it is 100 degrees. Therefore, the angle BAD is equal to 100 degrees. Our aim is to find the angle BCD. If you observe carefully, the angle BCD is the angle opposite to the angle BAD. And we know that in a cyclic quadrilateral, the sum of the opposite angles must be equal to 180 degrees. So, the angle BCD plus the angle BAD must be equal to 180 degrees, and from this, the angle BCD will be equal to 180 minus 100, which is nothing but 80 degrees. So therefore, the angle BCD is 80 degrees. So one part of our question is completed. For the next part, observe that in the problem it has been mentioned that the sides AB and BC are of equal length. So in the triangle BAC, the angle BCA will be equal to the angle BAC since the angles opposite to the equal sides are equal. Now given that the angle BAC is 30 degrees, so the angle BCA will also be equal to 30 degrees. And we just found that the angle BCD is equal to 80 degrees. And we know that the angle BCD is the sum of the angles BCA and OCD. So the angle BCD will be equal to the angle BCA plus the angle OCD. And from this, the angle OCD will be equal to the angle BCD, which is 80 degrees, minus the angle BCA, which is 30 degrees. So therefore, the angle OCD is 50 degrees, and we are done with the next part of this problem as well. So friends, that's all from this video and from this chapter. You need to learn how to use the theorems that we studied in this chapter to solve the problems, and you need practice for the same.